If you've ever installed floor tile, you know how critical it is to make sure you've planned everything out so that you're not left with a small piece once you get to the wall. Now, I recently installed a 6 by 24 inch tile in a strange L-shaped bathroom. And in this video, I'm going to show you how to accurately measure a room and bring that into SketchUp. You're going to be within 1/8 of an inch, plus or minus 1/8 of an inch here. Then I'm going to show you how to use SketchUp to plan out the tile layout, but also create an accurate takeoff so you know exactly how much material you need. Hi, I'm Matt from MasterSketchup.com, author of SketchUp to Layout and co-author of SketchUp and Layout for Architecture. Now, I actually have a background in carpentry, residential remodeling to be specific, and I've done quite a few floor tile installations. Now, if you've ever installed tile before, you know that with like a square tile or a rectangular room, it can be pretty easy and you don't really need SketchUp to plan it out. You can typically get away with measuring to the center of the room and either aligning the tile itself to that center line or aligning one of the joints to that center line, and then you'll end up with nice symmetry on each side. Or, you can also take into account any cabinetry or, obstructions that are going to be installed in the room. Now, you could use SketchUp if you wanted to create like an accurate takeoff of materials. SketchUp is a great way to quickly lay out any tile project in order to do that. Now, in this particular project, things were a little tricky because I was working with a 6 by 24 tile and it was being installed on a 45-degree angle. And just because of the shape of the room, things just were going to be really hard to try to lay this out in the field for a number of reasons. So imagine for a minute that I was actually using a square tile, so a 12 by 12 tile. So if you're installing a square tile on a 45-degree angle, it's actually not that much harder to plan out the installation, because if you look at the alignment of all of the lines, they're still parallel to the wall. So if you look at this wall here, and then if you look at the grout lines, they're parallel. So what this means is if you were to look at the main reference line that you might use to align the tile in the actual project on the floor, you could really just snap this line directly on the floor and then analyze how this tile interacts with the wall. And you would know that on the subsequent rows, it's going to look pretty much the same way. So this cut piece here looks the same as this cut piece, and so on and so forth. So you don't really need to see beyond this initial row that's directly attached to the reference line that you've created. However, with an oblong tile, in this case 6 by 24, it behaves very differently. You can see that if I project a line along the corners of the tile, it's not actually aligned to 45 degrees. So each row of tile gets closer and closer to the wall until it actually intersects and goes past the wall. So it's really important to be able to see the full picture of how these tiles are going to lay out in SketchUp. This is why SketchUp will be great for planning this sort of thing. To try to lay out every single row in the field is going to be really challenging. So the other thing that makes it really hard to plan this out in the field is just the shape of the room. So if you imagine we would have a main reference line going diagonally here to align the tiles to, we could actually measure most of the area of this room from this reference line. So in order to get these long tile rows measured out, this whole area would be covered. We'd miss a little bit over here, but it's such a small area that it doesn't matter. But then we'd also need to measure the diagonal lines so we can figure out exactly where the staggered grout lines occur. So we might decide to have a line here and a line here. Now, with those two lines established, we actually can't reach every part of the room. So if you imagine, we could measure out to here and we can catch these two tiles here, but we can't measure to this point or this point from this line over here. And then we do miss a little bit up here as well. So again, it's kind of minor, but to try to lay this out on the field, you can imagine, you're going to snap some chalk lines on the floor. You're going to check everything. If you find out that something is off by just a little bit, now you have to re-snap the lines. It just makes a lot of sense to try to lay this out in SketchUp. That way, obviously, you can just move stuff around and it's not a big deal. Now, before we jump into SketchUp, you need to measure the room. Now, we want to be very accurate here. So we can't just measure the length of one wall, the length of the other wall, because the lengths of walls takes no account for what angle is between those walls. So instead, what we're going to do is we're going to create two reference lines on the floor in the bathroom. And we're going to make sure that those two lines are perfectly 90 degrees from each other. And then we'll measure from those reference lines to each corner of each wall and create a coordinate for each of those corners that we can then reproduce in SketchUp. So at the end of the day, you're going to create something that looks sort of like this. So you're just going to draw it out on paper and you're going to have two dimensions for each corner with an arrow pointing back to which reference line that dimension is measured from. So to create your first reference line, you want to find the longest wall in the room, and you're going to measure a certain distance away from that wall. It doesn't matter exactly what the distance is. This has no relationship to the tile layout or anything like that. All we're trying to do is establish a reference line that is roughly parallel to this long wall. So pick a dimension, could be roughly halfway between the room, and you're going to mark one side of that wall on the floor. Then you're going to go to the other side of the wall, measure that same distance, and mark it again. And then you'll just grab a chalk line and either use a nail for one side, or if you have someone to help you, just snap a line on the floor there to establish your first reference line. Now, the second reference line needs to be as close as possible to 90 degrees from the first reference line. So in order to do this, there's a few different ways you can go about it. If you have a laser that shoots 90 degrees, that's probably the most accurate way you can do it. If you have a T-square, that sort of thing. You can also double check the angle using the 3-4-5 rule, also known as the Pythagorean theorem. So basically what that states is a squared plus b squared equals c squared in a right triangle. So you can also just use 3-4-5. So you measure 3 feet along one distance, you measure 4 feet along another distance of the triangle, and then the diagonal should equal 5 feet. And if it doesn't, you just need to adjust your angle slightly in order to have that perfect 90-degree angle. Now, once you have those two reference lines established on the floor, you're going to measure from those reference lines to each corner of the wall and just record each of those dimensions on your piece of paper that you can then bring back and record into SketchUp. All right, so now that you have all the dimensions written down, we can go ahead and start creating the model in SketchUp. You can use any version of SketchUp. I'm using SketchUp Pro, but if you're using SketchUp Free in your browser, all the keyboard shortcuts and tools that I mentioned here are all going to be the same. So it's just going to look a little bit different because of the user interface. The first thing you're going to do in a new SketchUp file is delete the person there. And we're going to create just a temporary surface that we can work off of, which is just going to help the SketchUp inference engine know that we're trying to draw on a single plane. So with the rectangle tool, I'm just going to create a rectangle that's a little bit larger than the scope of my project. So in this case, I'll go 15 feet, enter, and then with the select tool, I will triple click that and right click, make group. So this is just going to be a temporary surface that we use for reference. We'll delete this later. The next thing we're going to do is draw the two reference lines that we had snapped on the floor in the room. So using the line tool, we will create a line, click to start. Then we're going to use the left arrow key to lock the green axis. It's important that these two lines are perfectly aligned to the axis. So just make sure you see that green line as you're extruding it. And I will go ahead and click to place that and tap escape so I can start a new line segment. So then I'll come over here and tap the right arrow key in this case, so we're on the red axis, and click to finish, then tap escape to get out of the line tool. So if you want to measure these out perfectly so they're well within the scope of your walls, you're free to do that. I'm just kind of eyeballing it right now. I'm just making sure that these lines are a little bit larger, a little bit beyond the scope of the floor plan I'm working with. But if I need to, I can always go back in and extend those and make those a little bit longer. So at this point, I want to protect these reference lines so they don't accidentally get moved. So I'm going to triple click these with the select tool, and I will right click, make group, and I'm actually going to lock these as well. So I'll right click again and select lock, and then I'll just click somewhere off screen so nothing is selected. Now what we're going to do is create guide points for each corner of the wall that we recorded coordinates for. And the way we're going to do that is we're going to use the tape measure tool to first create a guideline, and then we'll measure off of the second reference line at the intersection to create a guide point. And then we can erase the guideline and we'll just be left with the guide point. Now, I actually noticed that sometimes you'll get a guide point like this where there's a tail, and then other times you'll get just the guide point without the tail. I asked the question on the SketchUp forum, and it pretty much, people think it's a bug, so you'll probably get mixed results here as you're drawing this. When I did the written tutorial on my website, all of these were just single guide points, so don't be alarmed if you notice that some of these have tails and some of them are just guide points. But let's go ahead and walk through one of these examples so you know exactly how to do this. So I'm going to do this first corner of this wall here, and so this I need to measure 80 3/8 to the reference line that's along the green axis. So I'll start at the reference line here, I'll click once, I'll drag it out, and I'll type in 80 3/8, quote, enter, and that just snapped to 80 3/8. And then for the other dimension, I'll go to the intersection, I'll drag up, and this is 27 5/8, and there's my guide point. So I'll do another one. The next one is 31 1/8. And this intersection is 27.5. And then once you've done that, just grab the eraser and go ahead and erase those the two guidelines, just so they don't get in the way as you start going around the room and doing the additional walls, so you don't have like a ton of guidelines in the model. So once you've added all the guide points to your model, then you just need to go around with the line tool and connect all the dots. So the thing to be very careful with is you need to make sure that you zoom in far enough to make sure that you're actually snapping to the guide point and not just arbitrarily snapping along axis, because when you measured everything, you recorded everything incredibly accurately. So the walls are not going to be aligned to the axis. So you just need to make sure you zoom in far enough. See how close this is to being on axis? I need to just move over a little bit. And sometimes when you're zoomed way far out, it's hard to know for sure if you've hit the guide or not. So you're just going to go around the model, making sure that you're snapping. And when you get back to the beginning, you'll have the floor with your wall outline inside SketchUp. So you just want to turn that into a group. So just triple click it if it's not already selected. And at this point, we can go ahead and get rid of the reference surface that we created here. So now we can start modeling the tile. Now you don't want to just go by the measurements that are on the box. You want to measure a few tiles and try to identify like an average dimension for the tiles. So in my case, my tile is 1 foot 11 11/16 by 6 1/16. Now you might notice when you draw that you get this Z fighting on the surfaces of between the surfaces of the tile and the floor. Now, that's just because you have two faces that are literally on the same plane, and SketchUp is trying to figure out like which face should face the viewer. So one quick way to just alleviate that visual effect is to just turn on X-ray mode. So if you have your styles toolbar turned on, you can click that right there. Or alternatively, if you go to the view menu, face style, X-ray, that'll turn on the X-ray mode. So with a tile created, we want to turn that into a component because we're going to use this component to copy throughout the entire project. So that'll just be a triple click with the select tool and then press G on your keyboard, or you can right click and make component. So this one will be called full tile. So this is going to represent all of the full tiles throughout the project. Now to start copying the tiles and create, the pattern of the tiles, you don't want to just measure, the width of the spacer you're using and then just do the math, because you'll find that as you lay out tiles with actual spacers, it's not quite exactly on the mark. So a better way to do it is to actually physically take like 5 or so tiles, lay them out on the floor and put all the spacers in between them, and then measure that full distance along the span of 5 spaced out tiles. So in my case, I have a dimension of 9 feet, 11 and 3/8. So I'll use the tape measure tool to just create a guide at 9 feet, 11, 3/8. And then I'll grab the move tool and I'll click at this top corner. I'll tap Control to initiate making a copy. I'm going along the red axis, so I'm going to tap the right arrow key. I always love using those arrow keys to lock axis. And then I'll snap to that guide, and then I'll divide by 4, press enter, and now I have a very accurately spanned set of 5 tiles. Now, depending on the size of the room, this could be like really super accurate. So it's a good way to just keep that accuracy really high when you're doing this. So at this point, I would recommend selecting those tiles that you just created. So just by holding down the Shift key as you're clicking with the select tool, you can select multiple. You can also use the Control key. And then we're gonna make that into a group. So you can right click, make group. I have a custom keyboard shortcut, Shift G. So now this is a group that you can see here. And at this point, we can go ahead and rotate this group. So we can just select it once, tap M for the move tool, and then hover over one of these red handles and rotate that 45 degrees. Now I'm just gonna erase this one guide here just so that's out of the way. Now that we have these tiles grouped together, we can double click to jump inside and continue editing. Now, one thing to notice is because we created this group before rotating, the axis is aligned in relationship to the tile. Even though we rotated the group afterwards, that axis orientation remains relative to the inside of the group. So there was a certain reason why we rotated it after the fact. So now that we have one row of tile, we need to create a second row. And this particular layout is going to be staggered. So we need to be able to align to the center of the grout joint. So one thing we can do to help us do that is create an offset in the tile to represent the grout line. Now, since we actually span these tiles out over the course of 5 tiles, the actual measurement of the spacer isn't going to be exact. So instead, we will double click on one of the tile components to enter that component. We'll tap F for the offset tool, and then we'll just offset that line and snap to the tile that it's next to. And this is going to create some overlapping geometry since all these components are, next to each other. And so what I'd like to do is just delete that face that represents the grout line. We don't really need that there, and we should be all set. Now, if we were to go and try to copy this tile from the midpoint up to this midpoint, we actually don't have anything to snap to. There's no line that represents the center of the grout line. So we just need to add one more line segment just to give us a place to snap to. So I'm going to jump back inside one of these tile components, and just right up here in this corner, I'm just going to grab the line tool and create a single line segment there. That way we can snap to it. Okay, so now jumping back outside, I'm going to select all of these tiles. I could also just drag a selection box if I wanted to. And I'm going to grab the move tool and snap to the midpoint of one of these tiles. Actually, I want to, well, it doesn't matter. I'm going to snap to the offset grout line we created. So I'm going to tap Control to signal that I want to create a copy, and then I'll snap to that small line segment that we just created. So now you can see we have this nice staggered effect, and it's just a matter of repeating that process as many times as you need to create the full layout. So you just want to make sure all the tiles overlay over the entire floor. Now that you have all the tiles copied out over the entire floor, you can exit that tile group and manipulate the entire tile group as a whole in order to analyze the position and make sure you have a layout that you're satisfied with. Now, one side note to mention, you might want to use a top view while working in this project. You can go to Camera, Parallel Projection, and if you don't have this view toolbar, you can go to Camera, Standard Views, and Top. So one of the reasons why I decided to go on a 45-degree angle with this project is because I actually don't have any means to cut a 24-inch tile. So I was really crossing my fingers that I would be able to align the tile to this small 45-degree wall. That way I wouldn't have to make a cut along that long edge of the tile. Now, one thing I noticed here is this little 45-degree angle wall isn't exactly 45 degrees. Now, if we hadn't been so careful measuring out the wall placement of each corner, I never would have seen this. So in this case, I can actually align the tile to this wall and then grab the rotate tool and rotate it so it's actually parallel to that wall, because that's really going to be the longest edge that is going to be visible. It's right at the doorway. This is the doorway here where you walk in. So I wanted that to be parallel. And so at this point, I would just walk through the entire model and just look at every single intersection of the tile and the wall. Now, this project has a lot of opportunities for a small tile to end up being cut. So, there's every single corner, every single plane is just another opportunity. So because I was trying to keep everything aligned with this 45-degree wall, I would just create a guide along that wall. So you see this guide here. And then now I can use the move tool to move the entire tile surface along that plane to cross my fingers that I would find a position that I'd be happy with. So this is what I came up with. So I have a good layout at the door, which was important. This surface looks pretty good over here. This is where the vanity is going, so I'm not really too concerned, but obviously it ended up being fine anyway. I do have a small little tile piece here and here that ended up being kind of small, but other than that, everything really laid out nicely. So once you find a position that you're happy with, you can go ahead and jump inside this group and just grab the eraser tool and erase everything that is completely outside of the range of the floor. So I can't delete this one because this little piece is inside the floor. So you just go around the entire model and clean it up. And you can use a right to left selection. And if you see any tile that's within it, to maybe drop down a little bit lower and delete all at once. Do the same thing here. No, that can't be. So that looks good. And we'll do this one here. And if there's a few that are within that you need to remove from your selection, you can just hold down the Shift key and click those. So Shift key actually adds or subtracts selections, and then delete. And finally, we have these two and this one. So I'm gonna just add a color to these tiles just to make them look a bit different. Okay. So the thing that's nice about this method is you can select a single tile and go to the entity info window and see exactly how many tiles are in the project. And it looks like I'm missing one right over here. So I'm just going to add that one back in. Okay, so if this is as far as you want to take it, you can just end here. You can just select a single tile and you know exactly how many tiles are in your project. The other thing you can do is if you jump inside of the floor group, you can select that and you know the exact area of the floor. So for your thin set calculations, you know exactly how much thin set you need. So if you wanted to be even more accurate, you could actually account for all of the cutoffs that you make with each tile. So when you cut off a piece of tile, that piece that's left over ends up being used somewhere else in the project. So in order to do that, you want to jump inside of the tile group, and you want to select one of the tile components, right click it and make unique. You want to make sure you do that. That way you're not affecting all of the other tiles in the project. And once it's unique, you jump inside, grab the line tool, and we're going to just divide this face where the wall intersects. So now you can select the cutoff piece and press Control C to copy and Control V to attach it to your mouse cursor. And then you can just go through the model and find a nice piece that you want to replace with this piece. And then you can just fine tune the position and lock it in place. The nice thing about doing it this way is you still have a single component that represents that full tile that was cut, but you also have the association between the original tile and where the cut piece is being accounted for. So what's great about that is, so once you jump out of that component, you want to make sure to just delete the full tile that you've replaced. And now if you drag a selection box over all of the tiles, you'll see you still get an accurate count of the number of tiles that are in the model. And you'll also be able to know how many full tiles that you have in the model by just clicking on one of the full tiles. So this is what you would end up with if you went through the entire model and accounted for all of the cutoffs and all of the and left all of the full tiles. So I can see that I have 64 tiles that I need to purchase. And of course, this doesn't account for tiles that break when you try to cut them or if you make a mistake. So obviously you want to, add on more to account for those things. In my case, I actually didn't go through all of this to plan it out. I just thought it was kind of interesting to use it as an exercise to see that you could do it in SketchUp. And really on like a large project where maybe it's an apartment project where there's multiple tile floors that repeat themselves throughout the project, if you can plan it out to this level of detail, that's definitely going to allow you to plan it out more efficiently and be more accurate with your material takeoff. So once you have this all planned out, I wouldn't recommend actually cutting out all your tiles based off of what you show here in SketchUp. The crazy thing though is I probably could have. I ended up being within like a quarter of an inch to mostly an eighth of an inch of what I had planned out in SketchUp, which is really crazy. I wasn't even trying to do that. I was just trying to be as accurate as I could. That way I knew where the pieces were going to land. But in reality, what you're going to do is to lay this out in the field to actually start tiling is you would figure out exactly where you want your reference line to be on the floor to align your tiles to. So in this case, I chose this nice long diagonal line as my main guideline, and then I just measured from the intersection of my reference lines to the tile. So right there, right at that intersection. So 4 feet and 7/8 of an inch. So I went into the bathroom and I measured from those chalk lines that were snapped on the floor, 4 feet and 7/8. I did the same thing in this direction. If you remember, I had to rotate it slightly off 45 degrees, so it wasn't exactly square. So I got a slightly different measurement there. And then from there, you can use the 3-4-5 method to establish your diagonal grout line reference lines that you're going to snap on the floor to align your tile to. So that's it. I think this may have been more of a tile tutorial than an actual SketchUp tutorial, but I hope you enjoyed it. Please subscribe if you liked this. We're going to have more videos coming your way, and thanks for watching.